Okay, we're now entering the next section, which is we're going to use integrals in order to find volumes. Now this is kind of an exciting section because you can use this section to discover the volumes of shapes that you're familiar with. The formulas you learned in elementary school, they can help, like for circles and spheres and cylinders and things like that. Those formulas can actually be derived by problems like these. The idea is, if you've got a curve, and if you've got some curve like that, the question is, what would be the volume if we were to rotate this curve around the entire x-axis? And so you can see that it creates kind of a cup shape. And so the question is how much liquid could you fit inside of that cup? And the answer is that you can, because it's just been rotated, you can treat all of these like circles. So if this is from A to B, where we were doing this from, it's basically the integral from A to B of pi r squared, dr. And you'll notice that pi r squared is just the formula for the area of a circle, and that makes sense because these are all just circles with a radius. And what is the radius? The radius is whatever your function is at every value. And so that's where this formula comes from. It's just pi r squared, except that the radius at every moment in time is just the value of your function. And so if we just add this pi and we square the function, you get the volume of the solid that's made by rotating it around. So that's pretty much it. Let's do an example. Here we have the solid generated. We're revolving around 0 to 3 of y equals 4x. So y equals 4x is a line that looks like this kind of. And we're going to revolve it around 0 to 3, which will give us kind of this cone sort of shape. And so we're going to find the volume of that from 0 to 3. And we solve that by doing the integral from 0 to 3, because we're going from 0 to 3, that's what they tell us, pi, and then we just do our function squared. Because our function is the radius at every point, and it's honestly as simple as that. We just need to solve this integral now. I can pull the pi out of the integral, which is nice. So this is 0 to 3 of 16x squared dx. Just like that. And now we're ready to go. This will be pi times, this will be 16x cubed over 3, evaluated from 0 to 3. So pi times whatever that is equal to. Oops, I don't have a dx anymore because we're evaluating it now. So this is going to equal pi times 16 times 3 cubed over 3 minus 16 times 0 over 3. Like that. And I know I'm moving kind of fast. If you get lost, just rewatch part of it, or please email me if you have a question. This term collapses into 0. One of these 3's will cancel, so that's just 3 squared. So the answer is just pi times 16 times 3 squared, which is 9 times 16 times pi. And if we do 9 times 16, we get 144 pi, which indeed is the answer. And so that's how you do this problem. It's hopefully kind of straightforward. Kind of a fun application, and as I said, we can use this to find our geometry formulas that we know. Let's do one more example. Find the volume of this. We've got a square root from 0 to 18. So here we go. We've got the square root function, and we're going to go down to 18. And that means we're going to rotate it around the x-axis. And so we're going to find how much water this little cup thing would hold. It's called a paraboloid. We're going to find out how many units of water it would hold if we were to fill it up. Formula is the same as before. Volume is equal to the integral from 0 to 18 of pi times your function squared. And you might have been worried at first saying, uh-oh, I don't know how to take like the square root. That might be a difficult integral. But luckily the square root is going to cancel with the square, and this integral is going to be nice and simple. So this will be, I'll pull the pi out again. The integral from 0 to 18 of just x dx. Nice and easy. That's going to be pi times x squared, evaluated from 0 to 18. sorry, x squared over 2, because that's the integral. If you take the derivative of x squared over 2, you'll get x. So it's just pi times 18 squared over 2 minus 0 squared over 2. That's going to be your answer. And so if I do 18, don't cancel the 18 and the 2, obviously. 18 times 18 divided by 2 is 162. So it's pi times 162 minus 0. And so it's just 162 pi. And indeed, that is the answer. So you can see that these volume problems are not that scary. The integrals, sometimes the integrals are very difficult, but like on this one, if part of it gets canceled by the square, it actually ends up being kind of easy. Again, remember, this is pi r squared, where r is the radius of all these circles, pi r squared being the area of the circle. Okay, I think we'll stop this one here. We'll do another example in the next video. As always, email me if you have a question, and I'll see you in the next one.